Okay, we're going to be working on, again, solving linear systems. And this linear system, they've given us two equations. The only difference compared to before is we're going to be using a method called elimination, which we haven't done before. Okay? Just to recap, what methods have we learned in order to solve linear systems? What's the first one, Callum?
I'd say substitution.
Substitution, good. And there's still another we've learned. Michael.
Graphing?
That's right. Graphing. Okay. So probably the very first method we went through was the graphing. This last one we've done is substitution. And today we're going to go through elimination. You can use any three of these methods to solve this. You do need to know all three for your test coming up. Okay? So elimination. In order to solve elimination, our goal is to actually get rid of one of the variables. So there are two variables in these questions. Both of them have an x variable and a y variable. Now, right now, I've set them up almost like columns. The x's are on top of themselves, and the y's on top of themselves, and the constants just happen to be on the other side of the equal sign. We need to set equations up like this in order to use elimination. Luckily, they've already done it for us. So first step is lining up all the variables on top of each other. Second step is making sure the coefficients in one set of the variables are the same. Okay? Now, what I mean by that, a coefficient is the term in front of the variable. So for our x variables, we have a 10 and an 8. Those aren't the same. And in front of the y variable, we have a 4 and a 2. Those aren't the same either. So what we're going to have to do is actually find an equivalent linear equation for one of these. This is what we did a lesson or two ago. We need them to be the same. So in this one, what I'm going to try to do is I choose which variable I want to eliminate. I can choose to eliminate x, or I can choose to eliminate y. It doesn't really matter. Okay? I'm going to choose to eliminate the y's. And the way I'm going to do that is by taking equation 2 and changing the coefficient, or making it so that it's a 4. What do I need to multiply this coefficient by in order to make the value 4? 2. Okay? Now, some of you say -2. It doesn't matter if the operations are opposite. I just want the value of the coefficients to be the same. So I'm going to multiply the entire equation. Remember, whatever we do to one number in the equation or one term, we have to do to all of them. So my equation 1 is still the exact same. 10x plus 4y is equal to -1. And equation 2, I'm going to change the color, but it's still an equivalent equation. Remember, we did this equivalent equations before. The only difference is it's raised to a higher multiple. So 2 times 8 is 16x. -2 times 2 is -4y. And 7 times 2 is 14. So still the exact same equation, just different coefficients and constants. Now, if we look, my coefficients for y are the same. Perfect. The next step is I'm going to choose to either add these equations together or subtract them. I have to figure out which operation will eliminate the y. Which operation will cause +4 and -4 to equal 0? To add them together. Very good. Okay. So I'm going to add these two equations together. The setup is the hardest part about this. Once you have the setup, it becomes much more straightforward from there. So we're going to add column by column. We can only add variables that have the same variable together. So we have 10x plus 16x. What will that give us?
26.
Good. +4y plus -4y will give us what? 0. So I can put negative or +0. It doesn't make a difference. There's our 0. Our equal signs still come straight down, kind of like a decimal when you're adding and subtracting in elementary school. And -1 plus 14, 13. Good. This 0y is not going to be important for what we're doing, okay? We can kind of just drop it off. Because 0 times y is 0, it won't change anything. 26x is equal to 13. How do I get x by itself? Go ahead, Malik.
Divide by 15. I mean by 2.
Good. You got it. Just took you a second. Then we're going to be left with x is equal to 13 over 26. What's an equivalent of that?
0.5.
0.5 or a half. Good. So, let's quickly recap what we just did.
It doesn't matter if you take out x or y, right?
No, it doesn't matter. And what will happen is when eliminating, whatever variable you take out, we took out the y's, you'll end up solving for the other variable. So because we took the y's out, we found out what x is. Now, technically, I can use my substitution method, take this half and plug it into either of the equations to solve for the y. But instead, I'm going to go through this process again just so you guys understand it didn't really matter. This time, we're going to eliminate the x's. Okay? What will I need, or what will be a common multiple of 8 and 10? Yeah, go ahead, Michael. Okay, Malik?
4.
Okay, you're thinking of a factor. A factor, not a 10 either. I need a multiple larger than both. 80. There's a smaller one. Anyone know of another? 40. Let's use 40. A little easier to work with the smaller the numbers. So, what we're going to do is I need to change 10 into 40 and 8 into 40. What will I need to multiply both of them by? The first one, Malik?
4.
Yeah, we'll need to multiply the first equation by 4. And the second equation, to make it 40, what will we need to multiply by? 5. So, we have two new equations. Equation 1 will read 40x plus 16y is equal to negative 4. The other equation will read 40x minus 10y equals 35. Still equation 1 and 2. What we did is we made the coefficients the same. Now, remember how I said we choose whether to add or subtract?
That's it, we're going to subtract.
We're going to need to subtract in this one to eliminate both of the 40s. Good. So we'll subtract these. 40 minus 40 is going to give us 0x. 16 subtract negative 10y. What will that give us? 26y. Okay? That's going to give us positive 26y. And negative 4 subtract 35 will give us negative 39. Okay? Again, the x kind of drops off, so we have 26y is equal to negative 39. We're going to divide both sides by 26 to figure out what y will be. Y equals negative 39 over 26. Can I reduce this?
Yes. Would be 1/3.
No. Divide both by 13. 3. Good, you're right. Good job. 3 over 2. There we go. So we used elimination for both of them in this one.